let's just look at the history of programming here for a second. So we started with machine code and assembly language where you had to give every little detail. And then eventually we got compilers with languages like C and Java. That made things a lot easier. Then we got interpreters for simpler languages like Python, which made it even quicker and easier. And JavaScript, of course, we all know and love. And eventually we got vibe coding. And you can think of vibe coding as using LLMs as a compiler from natural language into some kind of machine code, whether it's Python, JavaScript, C. But what about the next step? What about using LLMs not as a compiler, but as an interpreter? What that would mean is that you can use natural language as the code, and you never have to generate code at all. And this would give you a lot of nice things. It would be completely bug-free because you can't have a bug in natural language. It would mean just in time because every interpretation could depend on all the situation around the natural language code that's executing. It could be personalized on a per user basis. And so that's how we built Shoya. And so we will Shoya. Let's see what it did here. So it looks very much like other vibe coding tools, chat on the left, preview on the right. But the big difference here is that if you look at what the agent actually did, it didn't write any code. It thought about stuff, it read and write files, but the files that it actually wrote is this natural language specification here. So you can see here's a bunch of information about the new YC website, very detailed, maybe more detailed than it needs to be. But when we actually loaded it on the preview, it's taking a really long time to load, and that's because the interpreter we're using here is Claude 4 Sonnet, so each page load takes quite a while. We'll optimize this for smaller models. But if we actually click onto our logs here where we loaded the initial UI, you can see it's actually reading the spec and deciding what to serve up for the user to actually see this website. So this might take a little while longer, but let's look at a different example, which is we built this like hackathon team finding app here. And if we look at an interaction example, let's say we want to send a message to one of the users. That's another type of interaction that happens. And the LLM gets the current state of the application on your screen. It gets the specific interaction, and it decides how to process that. So these two things, rendering the initial page and handling every user interaction, completely cover the basis of what you do in most web applications. And we do this completely with no code. Anytime it hits an edge case that's not expected, it can handle it dynamically because it's an LLM, and it can even go and update the spec to say how it'll be handled in the future. You can go and modify the spec manually if you want to, if you're not happy with one of these decisions, but you never hit a dead end where an exception is thrown because you're getting error. So this is Shoya, happy to take some questions.